Thank you. Yes, I'm Anirban Dutta, and my background is neuroengineering. So I work on developing rehabilitation tools that can help patients with different neurological disorders. This particular study was on functional neurological disorder, and this is the way NHS Inform Scotland defines it is a problem that FND describes it as a problem that is related to how brain receives and sends information to the rest of the body. And it's actually helpful to think of it as like the brain as a computer. And then so you can think of FND as a problem with the software and how the software is run, and without any damage to the hardware. So this is kind of how we can think about FND. However, the FND symptoms are quite varied. So it can go all the way from like arm and limb weakness, seizures to fatigue, pain. And due to such a varied symptoms, it's challenging to design a one size fits all tool. And yeah, so as a biomedical engineer, so my team took up this challenge, and the approach was to first understand the design needs. And we focused on a subset of FND. So this is with FND patients with motor symptoms, so it's functional movement disorder. So we first, to get the design needs, we had two patient advocates who reached out to the community with this idea of a biofeedback rehabilitation tool that can be used in a home setting, and what they would want that device to do for them. So this was sent out to, this was an online Delphi survey, and these people with FND were considered expert by experience, and they provided us feedback on yeah, the design needs. And so from those 20 FND patients, experts by experience, so we found that we can divide this FND tasks, so FND rehabilitation task into three different domains. So one aspect that we found from the survey is that so these symptoms, they fluctuate. So it's like unlike in, for example, in stroke. So if the arm is paralyzed, it stays paralyzed. However, in functional weakness, these symptoms fluctuate. Sometimes it's weak, sometimes they can move, but not as strongly. So, and what we found from the survey is that this actually is kind of related to the stress. So it can be like psychological stress, physiological stress, but more than stress, it's essentially the physiological response to the stress. That's very individual. So for the same stress, different people respond differently, and that in fact is somehow related to the symptoms in FND patients. So that's one aspect. So that's why we had this one task. Now, since there's so much, the symptoms are so varied. So we had to, the next stage was to do a co-design. So co-design is where we have design inputs, and then we work with, again, expert by experience, FND patients, and also clinicians who have worked with FND patients to then see the usability of different tasks. And it's kind of a iterative process. So you have to kind of go make a example and then have them try, and then they give feedback, and then you kind of make the next version, address those issues, and then kind of get the feedback again. So we ran only the first cycle of this usability study. So this is this co-design workshop that we have published in the in this JMER paper. So now, so like I said, so the first is this design task. So we made a example of that for relaxation in a virtual reality environment. The second, what we noticed is sometimes they are these FND patients with movement disorder, functional movement disorder, they are unable to move. So we had this second task, which is positional biofeedbacks, which is where we'll give a feedback of the position of their arm, and they again have to move in the virtual reality towards a target using that position feedback. So that was the second task. And the third task was if someone can move but cannot move as strongly. So they have this functional weakness. So they have some movement but not as strong a movement. So for them, there was this force feedback task. So this is using a haptic robotic device that can either help or oppose the movement. So These are all reaching tasks, so they have to reach a target. So these were the three tasks that we kind of met the first version. So we were working with a company, Neurological, who created these three tasks, and we then used that in the co-design workshop to understand how the FND patients and also the clinicians, they find these in terms of the usability. So this was the co-design one-day co-design workshop that we organized. We presented these tasks to the evaluators, and what we found is so this positional feedback was kind of received a strong usability rating from everyone. So this was so the score was above 85. So this is SUS scores, and so this was well received. Now, the virtual reality relaxation task that produced variable response. So some found it calming, and others found it discomforting. So this we have now realized that needs to be individualized based on individual response to the VR virtual reality environment. The third was the force feedback task, and that also had mixed results. So, like I mentioned, so some of these patients, they actually have fluctuating symptoms. So sometimes they have weakness, and then it then shifts to, for example, dystonia. And this is what we found, that while one of the patients was doing this movement, and there was this functional weakness, but as the movement was done, it actually uh, turned into functional dystonia, and the device didn't adapt, and that actually created discomfort. So again, the virtual reality force feedback task also needs to be adaptive. So this is not one size fits all. So that was the the insight from this first usability testing that we did with our virtual reality environment. Now, for future, what we are currently doing is we are now looking to the next version. So we are preparing, addressing these concerns that we found from the usability testing. And the other is to make this accessible. So we want this device to be priced such that it can be used in a home setting. And that's another challenge. So we may have to remove some of these tasks which may not be that helpful in terms of impact. So most likely the force feedback task. So we may limit it to, for example, VR relaxation and position feedback task, which can then be packaged into a product that can go in a home setting. So this is what we are working currently.